Good morning, all of you. Today we are going to study the topic activated complex theory of biomolecular reactions. This is the second theory. First one is the collision theory, and this is the activated complex theory of biomolecular reactions. So, biomolecular reactions, the specific molecularity are given here. So, this theory based on the idea that in any chemical reactions the reactant molecule must first form an activated complex or transition complex which then decompose to form the products. This we have studied in case of the SN1 and SN2 reaction also, because while drawing the energy profile diagrams at that time we have drawn at the bottom there is a reactant. We will draw 1 minute. We consider it is that the reactant molecules. This is the energy profile diagram. This is the energy. This is the reaction proceeds. So this is the reactant molecules. As the reactant molecule must form the first, that is the transition state. This is the transition state. At the transition state they having the highest amount of energy, or the intermediate that is also having the high amount of energy. Then there is the formation of the product, means the reactions has to be proceed through the transition activated complex. It is the activated complex, and then activated complex or intermediate, then converted into the product form. So this all explained by the activated complex theory. So this theory based on the idea that in all the chemical reactions the reactant molecule must form an activated complex or the transition complex which then decompose to form the product. So the reactant molecules having the sufficient energy and must form first collides, and redistributions of the energy and valence bond must take place to form the activated complex. Total of the reactions depends upon the reactant molecules, and the reactant molecules depends upon its energy, because for the reaction to proceed the reactant molecules with a sufficient energy can be react, can break or form bonds, because while converting into the next step, so there is must be the formation of new bond or breaking of the new bond. Energy required for that. In the transition state, activated complex formation, the molecules need required energy so that they can form bond, they can break a bond. This is the important conditions for the each reactant molecules. Activated complex having the short life and break up into the products. It is a fractions of second directly converting, because it is the highest top level of the energies, and the activated complex energy high. We know that as the energy increases, as the amount of energy increases, stability is also decreases. Energy and stabilities are the inversely proportional to the each other. That's why as the activated complex forms, they are having the highest amount of energy, and as they are having the highest amount of energy means the least stability, means they can be break up into the product, means they can last for the fractions of the seconds and convert it into the products. So it is a very short life activated complex. Next, since it has a transient or mandatory existence, hence it is also called as transition state complex. Why it is called a transition state complex? Because it has a transient and mandatory existence, having the very less time existence, hence it is called a transition state complex. We have studied this in the transition state. We have in the last years, I think, or in the 12th class, we have studied the energy profile diagram of the SN1 reactions. We have studied the energy profile diagram for SN2 also, and so I think in FY BSc we have studied I taught you the energy profile diagram for the E1 CB reactions, I think, or for the E1 reaction and E2 reactions. At that time, so we have draw on the graph the transition state points. So this is transition state points, the transient and very less time existence. Hence, we name it a transition state complex. The energy of activation of the reaction is addition's energy which the reactant molecule acquire in order to form the activated complex. So formation of the activated complex required a high amount of energy, and this amount of energy is required in the form of energy of activations, and this is activated molecule get molecules to acquire the activated complex state. So EA means activation energy is equal to EAC activation energy minus ER activation energy final. Means here the terms, the meaning of the terms is the EA means activation energy, EAC means the energy of activated complex, ER means energy of reactant molecules. This difference is between the reacting molecules and the transition state molecule and the reactant molecule. That difference give the actual amount of activation energy that molecules have. So this actual amount of activation energy is more, means the molecules having the easily the transition state complex or activated complex. If this amount of energy is less, at that time this required some external sources and not sufficient amount of energy, so that this difference is big. This one is sufficient so that they can acquire the activated complex. So activated complex lies at the top of the energy profile diagrams. Here the diagram is also given. So here is mentioned that activated complex at the top of the energy profile diagrams. So activated complex lies at the top of the energy barriers separating the reactant from the products and systematically written as. So here is the diagrams given. Here is systematically mentioned here. Systematically mentioned here is the reactant molecules. It is the reactant molecules. This is the activated complex, and this is the product. Systematically, there is a difference between the reactant molecules and the activated molecules. So this difference between the reactant molecule and activated molecule is denoted by EA. EA is equal to difference between the highest and lowest. Highest is the activated complex, the EAC, energy of activated complex minus energy of the reactant molecules, means we will get the EA. This is the EA value, EA energy of activations. Then the reactant and the product difference, this delta H denoted by the difference between the reactant and product. The reactant having the highest energy means energy of reactant minus energy of the product, we will get a delta H. So this is the diagrams, this is the energy profile diagrams explain all this. So the activated complex lies at the top of the energy barriers, separating the reactant from the product. Systematically written as the reactant is convertible into activated complex, which is converted into the products. So this is all explained in the diagrams, energy profile diagrams. The graph is between the graph for the one side for the energy, another side for the progress of the reactions. Next, rate of the reaction is given by the rate of the decomposition of the activated complex into the products. The rate of the reaction is given by rate of the decomposition of activated complex into the product. Example, in unimolecular reactions, the activated complex consists of only one reactant molecule with sufficient energy of activation and give the product by the proper movement of the different parts of the activated complex. Here is the example, best example, that is N2O4 reacted molecules. Then there is a formation of activated complex, that is ONO. So transition state forms means which bond breaking, which bond formations. That forms are given. Then product is a N2O4 product, means one oxygen less products, means this is all about the formation of the unimolecular molecules. The unimoleculars. In case of the bimolecular reactions, in the case of bimolecular reactions, the activated complex loses. The bimolecular reaction example is given, that is 2 molecule of HI, and that 2 molecule of HI forming the activated complex, and then product is the HI. So in the bimolecular reaction, the activated complex loses union of two reactant molecules and breakups into the products. So we will get the products that is having the two molecules of the hydrogen S2 and the two molecule of iodine. Both are the bimolecular reactant molecules and form the transition state, means the hydrogen and iodine new bond formation, and hydrogen bond breaking. This is the transition, one bond breaking, one bond formation, and we will get the product, that is the HI and HI product. It is the bimolecular reactions examples is given. Another example is the 2NO plus O2. This is also bimolecular reactions. Then that 2 molecule of NO2 and 1 molecule of O2 is given here, activated complex. We will get the 2NO2 as the products. So this is all about the reactions. So date constant of the bimolecular reactions on the basis of activated complex theory. The A plus B reactant molecules, activated complex X, and then product. This is given the equation number 1. So this equation is most important in case of the deciding the how rate of the reactions formations takes place. So we will discuss the remaining part of this reactions so that we can understand the overall rate, how to find out the rate of the reactions. We will discuss it into the next lectures. Thank you very much.